Welcome to the FluidNexus AcuSolve Workflow Introduction presentation. FluidNexus is an innovative CFD preprocessor, based on unique abstract modeling technology. Altair AcuSolve is a market-leading FEA-based CFD solver. AcuSolve preprocessing is made faster and easier with FluidNexus. Being a finite element solver based on Galerkin least squares formulation, AcuSolve is pretty liberal with mesh quality requirements. Just make sure that there are no negative volume elements in the mesh and maintain proper size gradation in the mesh. In addition, being a node-based solver, it works pretty well with tetra elements and boundary layers. This relieves user from the difficult task of generating prism elements. FluidNexus inbuilt meshing or mesh sim is based on time-proven meshing algorithms by Symmetrics. Mesh sim's robust, fully automatic algorithms provide best-in-class meshing for AcuSolve. In addition, mesh sim's structured tetra mesh generation algorithms, that is boundary layers and extrusion, add a great value to already robust node-based AcuSolve solver. AcuSolve is best-suited solver for integration with FluidNexus abstract modeling workflows. FluidNexus supports complete AcuSolve physics. FluidNexus AcuSolve workflows has been time-tested over the years by our valued customers. Here is a brief overview of abstract modeling AcuSolve workflow. A CAD specialist prepares a tagged CAD model for FluidNexus. Simultaneously, the CFD specialist authors an abstract model in FluidNexus. Synchronization of abstract model and CAD model in FluidNexus cascades all meshing and other solver attributes onto the geometry. Then, user generates the automatic volume mesh in FluidNexus. Then, user exports the AcuSolve input files ready to run. This slide here summarizes the complete workflow in 3 simple steps. Create simulation model. Create mesh model. Export AcuSolve input files. This is what we call, from CAD to CFD, reliably, in 3 simple steps. Users can also use Python scripts to automate the production model or a suite of models. Exported files consists of AcuSolve input file and the mesh connectivity files. The files input files are ready to run on your machine or cluster with AcuRun command. Here is a quick demonstration of FluidNexus production mode for AcuSolve solver model. We are ready with the FluidNexus abstract model and the CAD model for our simple fan model. So let's start FluidNexus graphical user interface with Creo and Mesh Sim Mesher. Let's open our abstract model, which has all the required classes and attributes. We will now execute 3 simple steps to generate the AcuSolve input file. Step 1. Create the simulation model using the tagged CAD model. Step 2. Create the mesh model in FluidNexus. Step 3. Export the AcuSolve input deck to a directory, say blower. Let's check our blower directory. The directory consists of a AcuSolve input file and the mesh. The AcuSolve files we just created are ready to run on a workstation or the cluster. Here are some checkpoints to follow during CAD modeling. There should not be any solid interference or self-intersecting surfaces in the model. Eliminate any edges below 0.2 mm in your CAD model. Apart from above, PTZ Creo model should be prepared with absolute accuracy, preferably below 0.004 mm. Robustness of finite element-based AcuSolve solver eases meshing job. Make sure you grade properly the mesh sizes across neighboring regions. If your model is having thin gaps, make sure to enable Ensure Interior Vertices in Mesh Controls. This ensure at least one node in flow path and avoid artificial plugging of flow. Just check the mesh statistics for any negative volume cells. Here are some snapshots of real-time models FluidNexus has handled. A blower. A heater. Powertrain. Thanks for your valuable time and feel free to contact us for further inquiries.